Hi, welcome to my latest video. Today I'm going to film part one of a video series looking at tuning the Freelander 2 for increased performance. So I recently did a video showing possible projects that I could do next on my car. There were about 14 different projects listed, and I talked through each one, and then I asked my viewers to vote for the video that they would like to see next. And the winner was a video about the turbocharger, which is fitted down the back of the engine. Here's what it looks like. Here's one that I bought on eBay, which is in a bit of a state, has seen better days, but I thought having a spare turbo would be a good idea. You never know when that kind of thing might just fall off the car as you're driving along. And it also allows me to dismantle this and show you all how it works inside. Okay, so let's talk very quickly about the induction path on the Freelander 2. So it all starts right over here on this wing air vent. The one on the other side that looks like this is a fake, doesn't do anything, no air goes through it. So the air goes in there, down a duct, a black plastic duct in the wing, round a sort of a kind of horrible cardboard duct, which I've replaced with blue silicone, into the air filter box, up through the air filter, and then your Freelander 2 probably has a black plastic duct across the top of the engine. Now I've replaced mine with silicone and aluminium hose joiners. The reason I did that is because I got fed up with the oil and fumes which was coming out of the engine breather from the bottom of the crankcase, comes up into the factory duct, which was then leaking out at all the various joints and making a real mess, and oil was dribbling down onto the turbocharger, the red hot turbocharger, and was making a real stink of burnt oil. Okay, so what I did was I fitted this so that pure clean air goes into the engine, and then the crankcase breather is routed to an oil catch can, which then just dumps out underneath the car. Although I might at some point be routing that back in here for the MOT, because I don't think you're allowed to just vent to atmosphere for the MOT. I think it's one of those things that's at the tester's discretion. So I'll probably play safe and connect it back in using a sort of one of these with a little spur pipe sticking out. So even with that routed back in, the oil is caught in the can, and that's what's meant to happen, and then it'll just be fumes going in. But I much prefer this setup with 100% clean air going into the engine. Petrol and diesel engines need air to run, and that air really needs to be nice, clean, filtered, oxygen-rich air, not fumes from the bottom of the engine and oil mist, which will pollute the intake charge and reduce the performance of the engine. So whichever type of intake you've got here, I know some of you have copied me and done this sort of intake on yours. If you've got the black plastic duct, it will then connect onto here, and that goes down and into the turbocharger. So if I just try and position this turbo kind of how it is on the car, so it's something like that. Okay, so this black plastic duct there goes down and into here. There's a kind of weird sort of big black rigid plastic sort of balloon thing that kind of goes on the end, and the air goes in to the compressor, which is spinning, compressing the intake air, and it comes out the bottom round a right angled hose, which often splits, so I've replaced with blue silicone hoses, across the engine, up through the intercooler at the front of the engine, which cools down that compressed air using air from the atmosphere that's coming through the front of the car. Cooler air is denser, so you get more oxygen molecules for every litre of air that the engine's sucking in, and more oxygen means more power. So through the intercooler, and then it goes across and up the front of the engine. Now you can just see a blue hose there. This hose here is probably the one that splits the most often. About a month and a half ago I filmed a video showing the replacement of that hose. Very, very common fault on the Freelander 2. If it isn't the hose down there, it'll be the hose here. So if you ever get the check engine light that come on and a loss of power, possibly a sort of a whooshing noise kind of coming through what sounds like coming through your heater, sort of behind the bulkhead, is actually the turbo spinning up extra fast because it's pumping air which is then leaking out, and the manifold absolute pressure sensor, which is this device here, is then saying, I haven't got enough pressure, give me some more boost, give me some more boost. And the turbo goes faster and faster and faster and faster, and it can never reach the point where the sensor says that's enough, you can stop boosting now. Okay, so the turbo will spin up and you'll hear a kind of a whooshing noise. The air fuel ratio will all be wrong as well, so you might even get a load of smoke coming out the back. So common fault, that split hoses. This one down here is a little bit fiddly to replace. You can just, if you're lucky, you can reach down and just pull the old hose out and put the new one on. I actually opted to take the whole throttle body out. Good opportunity to fit a new throttle body. They're about £100 online, on eBay and other websites, and the plastic gears inside the sort of motor unit, because it's an electronic throttle, motorized, kind of servo controlled throttle butterfly. The plastic gears wear very easily, and then you'll end up with a kind of scratching noise. So you'll switch off the engine and you'll hear this down the front of the engine. Sounds like a rat chewing its way out the front of the engine, but it's the gear teeth sort of jumping and skipping and generally stripping themselves as they're the motor is trying to turn the throttle butterfly closed in order to shut the air off and stop the engine, but it can't, so the engine ends up sort of spluttering slowly to a halt, and you get a load of weird sounds. So hose down here and throttle body probably will need replacing, I would say, every 50,000, maybe 60,000 miles. I did my throttle body the first time at about 60,000. I'm on the second one now, that I could probably do with renewing that at some point, and I did the hose. The hose actually lasted a long time. I'm on 155,000 miles now, and that hose is only just split, but if you're unlucky, yours will split a lot sooner than that. So the way in which the boost is controlled on these turbos is using what's called variable geometry setup, or variable vanes. So older turbochargers have what's called a wastegate on them. So what that is instead of this box here, there is a sort of a pneumatic diaphragm which connects to one of the intake hoses, and then at a sort of a certain boost level, it pushes a rod which opens a gate, and it allows exhaust gas bypass the turbine here and go straight round and out. Okay, so that's the way in which the boost is limited. You have to have some kind of boost limiter, okay, otherwise the thing will just spin up and up and up and up and up, make more and more and more boost, and it'll just be too much boost for the engine. You'll probably end up damaging the engine or splitting a hose or exploding something. So on these ones, they have an electronic actuator. Okay, so the way it works is that the exhaust gas comes out of the engine, which I think is here, round the turbine and out and down the exhaust to the back of the car, and that turns the compressor, which compresses the intake gas, which we talked about a moment ago, which goes all the way round and up and into the engine. And as the turbo speeds up, the boost level will increase to a point where the manifold absolute pressure sensor here generates a voltage signal that is at a level where the engine computer says, oh, okay, we've reached maximum boost, we need to limit that boost now, otherwise we're going to do some damage. And it sends a message to the electronic box of tricks here, which is basically a motor. It's really another servo, a bit like the one in the throttle body. So there's a connector here, inside there's a motor and a feedback variable resistor, and this kind of lever here, this kind of cam mechanism here will rotate and either push or pull this rod. I'm not sure which direction this goes in, but it then moves this lever, and inside here, all of the way round the turbine, the exhaust turbine, are sort of like vanes like that, like fan, sort of like a flaps basically, kind of going round, which adjusts their angle in order to direct the exhaust gas in towards the centre of the turbine for lower speed, or they'll level out so the exhaust gas whizzes around the outside and spins the turbine faster and faster. So imagine that you've got a water wheel and you've got a sort of a jet of water spinning the water wheel round. If you point the jet towards the centre, it's really not going to turn very fast, but if you move it out and you point it around the outside, it's going to spin up to maximum speed. So that's what those vanes do, those variable vanes inside the turbos. They angle in to slow the turbo down and reduce the amount of boost that is being generated on the intake side here. My idea is to, first of all, we'll take this apart, we'll see how it all works. But my crazy idea is to see if it's possible to do something with this linkage and this mechanism, either mechanically with the linkage or electronically inside the box, to get this to either move later at higher boost, so that the boost builds up more before it starts to limit it, or do something so that this just moves less. So if this point here was brought up here, so if this piece was rotated round, the first part of the movement would not push that down. It's only much later that it would start to push that down. Okay, so the result would then be much higher boost coming out of the turbo, out of the intake side here, and then higher boost would be generated going into the engine. Because I haven't done anything to the manifold absolute pressure sensor, that will send the correct reading to the computer so that the fuel air ratio and the amount of fuel being injected by the injectors is still correct for the amount of air. There is one thing that I need to be careful of. If I take the boost too high, the ECU will throw an error. It'll say, hang on a minute, what's going on here? Our turbo actuator is not doing its correct thing. It's not limiting the boost to, let's say, 10 psi. Don't know what that is in bar, 0.7 bar. It is in fact allowing it to go higher, to say 12 psi, or we're going to throw a fault condition. Okay, and the car will probably go into limp mode and there will be error codes logged, which will need to be cleared. So really, if I am going to mess around with this, I need to be careful that I don't increase the boost too much. I have seen some people, not on Freelander 2s, but on other cars, actually interfere with the output from the manifold absolute pressure sensor and actually sort of put a resistor or a Zener diode on to limit the output voltage, to trick the car into thinking it hasn't yet reached a certain boost, and it just keeps boosting more and more. But the problem with that is it's that feedback signal, that voltage, that controls the fueling, along with other things, of course, engine speed, load, blah blah blah, but air temperature and everything else. But this is quite a major factor in the fueling calculation. So if we start messing around with the voltage coming out of that, then the engine could be running lean or rich, and that's not going to be good at all. Okay, so I'm really keen to keep the fuel air mix correct. We're just going to allow that boost to build up a little bit more, not a lot, maybe say 5% more, 10% more, no more than that, just to get a little bit more horsepower out of the engine. Don't want to start stressing the drivetrain and the prop shaft. This is not going to be turned into some sort of fire-breathing dragster. Just want to see if I can get a little bit more power out of this. Could be something as simple as a new, slightly redesigned linkage here. That could be all that is needed. But this is just part one of this video. What I'm going to do now in this video is start dismantling this turbocharger. We'll have a look what's inside. We'll have a look what's inside here, and we'll see which way this moves and by how much. And we can have a look at the vanes in there, so you can see how they move when the boost level, maximum boost, is reached, and the ECU tells the turbo to limit the boost being delivered. So I'm now going to start dismantling this turbocharger. I'm going to start off by removing this actuator from here, which is held on by 3 bolts, one with some kind of red paint or something on it there. Hopefully that's not welded on. And I will disconnect this linkage here, and once this is all off, I'll start getting at these bolts here and remove this kind of exhaust turbine housing, followed by this piece here on the intake compressor, and we'll have a look and see what's inside. My thinking at the moment is that there may be 2 possible ways to trick this into generating more boost. First of all would be a mechanical method, so replace this linkage and possibly rotate this round, or even replace this piece here, so that the movement of this shaft, or this sort of connecting rod, is different. You know, what I'm thinking is, if I can get it to only push the vane adjustment lever right at the sort of top end high boost, then the overall boost might build up a bit more in the meantime. The other second method that I'd like to look at is actually doing it with electronics. So inside here there will be a circuit board and a motor and possibly some sensors or feedback resistors. I'm thinking I can do something to that to actually alter the behaviour of this shaft that turns. So if I can somehow make it rotate later, or delay the rotation or something like that, then it's a possibility that the boost might build up a bit more before the vanes get moved. And both of those ideas are possible solutions to generating a bit more boost, but I don't know at the moment which way would be best, or even if either method is possible. So I'm going to take it all apart and get a clearer picture of how it actually works, and then I'll be able to decide which if any of those methods might actually work. Okay, so I've just removed this little circlip here, and that allows this actuator arm, or actuator rod, to be disconnected. Now we can see that there's actually a reasonable amount of movement in that lever there. So the position that it was in was about halfway on the travel of that arm. Now, it doesn't necessarily mean it uses all of that travel when it's operating, but looking at the angle of this, I would say that if that was up here, it would be fully pulled in that direction, and then roughly 90 degrees round from there, it would be in full travel in the opposite direction. Now, I don't know at the moment which position is vanes pointing in or vanes pointing around the outside. I think we'll have to call it sort of high power and low power positions. Once I remove this, we can find out which of those two positions is the high power and which is the low power. Okay, so I'm going to carry on removing this other clip, take this off, undo these, take that off, and then we'll tackle this piece here. Okay, so I've removed these two bolts here using a 10mm socket. This one here had some kind of orange paint, or I don't know if it was thread lock or orange paint, which is still sort of attached to the bolt head, but I've managed to get the socket on it and rotate it. I think it was just some kind of like thread lock type of thing, just to stop it coming loose. Okay, right, there is the turbo actuator. Okay, so it's worth mentioning that this will not move. I think there's a worm drive in there. Okay, so that will not rotate and sort of push against the motor. I think it's a motor with a sort of worm drive, and then a cog, which is allowing it to be motor driven in one direction, but not moved by hand. So what I'm going to do now is prise off these clips and have a little look and see what is inside here. Now, it's interesting that this is actually a Garrett Turbocharger. We've got Halle, made in Germany, and we've got 5 pins in the connector. Okay, so we'll try and work out what those do when I get the cover off. Okay, so I've removed these metal clips. There are 6 of them in total. Just kind of popped them off, and now this cover is coming off. Okay, there we go. Right, circuit board. One chip there, which suggests that this actuator is sent commands rather than just told to open and close. Yeah, what I'll have to do is trace the circuit board there from the main connections round to these other connections here, which are probably connected to the motor. Okay. Right, there's two connections there which go onto that there. I don't know what that weird comb thing goes onto. That goes that way. So that thing there, which is one piece of metal, it's not a sort of connector, that actually pressed down the side here. So maybe that's just an earthing kind of connection there. And then there's two connections there. So that's interesting that there only seems to be 3 connections from the top half to the bottom half. Okay, so I don't know what these pins here are. They sort of stick out, but there's nothing here for them to connect onto. Okay. So what have we got here? We've got a motor, which is held in by a sort of spring, and something here. I don't know if these are resistors. They could be resistors rather than springs. I don't know. Difficult to tell, really. And then this weird looking thing here, which I'm guessing is the sort of feedback somehow. I mean, this, I don't know how that works at all. That's not kind of like a sliding contact on that. As far as I can see, there's no metal on this here. So it might be optical or it might be magnetic. There's nothing under there. No sort of photodiodes or anything like that. So I don't know what these odd holes are here. So somehow the position of this must be fed back to prevent the motor just running and running and running. So the motor will turn. I can actually move that worm drive there by hand. And we should see, yeah, we should see that slowly moving. And then somehow it must know that it's moved far enough. Ah, okay, so that's now hitting an end stop. Okay, so you can see the end stop down in there. Okay, so that's one end stop, and that's with, let's have a look. So that's with that there. So that's one end position, which will push this lever here fully that way, that is fully that way. And then the other motor end stop will be back up like that. So let's just see how far it goes. So that, if we look at that, this is, if we say this is a clock and that's 12 o'clock upwards, that's a kind of 4 o'clock position, just past 90 degrees. So let's move this by hand the other way. And just see how far it will go. And there's another end stop there, which we can see. I'll just rotate this worm drive. There we go. Okay, so that is now on the other end stop. Okay, so there we go. That's pretty much 12 o'clock. I'd say slightly off, maybe 1 o'clock position. So it goes from the 1 o'clock position round to the 4 o'clock position. Okay, so that's the travel. I still don't know which is vanes in and vanes out, but what I'd like to do really is try and take this apart and work out what these copper coils are. I don't think they're springs, I think they must be resistors. Must be a resistor or something there, or it could possibly be like a wire wound variable resistor or something, but nothing. This doesn't move. This doesn't move, and that there's nothing's moved up and down those coils. Okay, I will dismantle this more. Unfortunately, this one here is all kind of soldered in, so that's going to be tricky to get that apart. I mean, I might have a go at desoldering that and removing that, but it does actually look like it's sort of glued in. You can see some like mastic behind the circuit board there. So even if I desoldered that, I don't think I'll be able to pull that circuit board out without damaging it. Those two at the top there seem to be possibly higher current. They just look beefier than the other ones. So maybe that's like 12 volts and 0 volts, and then you've got kind of 3 data lines, or a data line and two sort of feedback lines. What I do know is that if this actuator fails, the ECU gets told and it throws an error. I don't know what the error code is, but it definitely alerts the ECU. So somehow, if the motor doesn't move, or moves too far or whatever, if there's a general issue with this actuator, then it will throw a fault. So somehow this, if it doesn't work correctly, tells this, which then sends a message up the CAN bus or whatever it is to the ECU. So okay, right, I'm going to take this apart and just have a little closer look and see what's under here, what's in there, try and figure out what this funny blue thing is. Okay, so I've managed to get the motor out. Okay, so that motor was sat in like that, had this little gold coloured bearing on the shaft at the end. The bearing seemed to be a very tight fit into there, it just wasn't sort of freeing up. I think actually looking at this, there's a little tiny screw thread there. I don't know if there's a screw head in there, but I didn't realise that was actually a screw, a mounting screw. What I did in the end was I just lifted that end up and the motor came out. It's probably ripped the thread actually out of the little locating screw at the end. See that's loose there, but there's nothing there, so I think they put kind of like a blanking cap or something in the end, so you can't actually get at that screw. Then the motor itself was held in by this horrible, evil looking barbed clip, which you can see there where it's the teeth. So that was there, and I had to kind of prise that out by basically getting a set of pliers on it and ripping it out. So we can now see what's underneath. First of all, actually, before we have a look at the worm drive, this weird red-coloured, reddy copper-coloured coil here, it's not any sort of moving resistor, it's not a sliding variable resistor or anything. I think it is just a resistance to make the motor run slower. Either that, or it's an inductor to reduce interference. That looks more like a wire wound power resistor. So 12 volts comes in there, and it's then just connected to the motor with a resistance in series, just to kind of run the motor a bit slower. That's what it looks like. If you know differently, then please do comment below this video and let me know what you think those are. They are definitely copper wire, wound copper wire, like some sort of power resistor. I don't think it's an inductor. although I could be wrong. Might be just for interference suppression. Usually you would put a capacitor across the motor, I think, if I remember my electronics degree correctly. An inductor would go in series, not across it, so I can always get the meter out and test that out. Looking at this here, this weird thing, which I think could actually be a variable capacitance. Okay, so we've got kind of like a circular kind of track there with these little kind of radial tracks there, and I think when that is wafted over that, it will change either the inductance or the capacitance in that kind of weird spiral thing, and that's possibly how the chip measures the position of the basically the toothed rack there that the worm drive operates. So my thinking at the moment is I'm not going to be able to really do a lot with that electronics there. If it was simpler, I might be able to sort of put a resistance in series or something to kind of get the motor to delay its movement, but this is digital electronics there, so that's going to be far too difficult to hack into and do anything clever. One idea I've got though is that if I could remove this, and it looks like it's actually welded on, then that could potentially be refitted in a slightly different position, so that instead of the kind of mechanism here, if I put that back into there, instead of this moving from a 1 o'clock position to a 4 o'clock position, it actually moves from, say, 12 o'clock to 3 o'clock. And what that would mean is that the variable vanes in the turbo were held in the high power position for longer before being moved to low power right at the last minute, and when they are moved, they're not moved as far, so they would be moved to about there rather than there. Okay, so the turbo wouldn't slow down as much as it does as standard, and that would allow the boost to be maintained at a higher level for longer. That's one idea I've got at the moment. Might see if I can kind of drill out that shaft there. It's difficult to know which, I mean, this might be just press fitted. This here, it looks, it's difficult to tell if that is metal or plastic. I think it's plastic, you see, so I can't start wrenching that around, it will just snap off. So what I need to do is try to remove this. Now I'll try just pulling it. It might just be a press fit. There's probably a splined shaft underneath that and it's just pressed on. So I'll try and pull that out. Failing that, I might have to get destructive. I mean, this is never going to be fitted to my car. The intention was that if I could do something with this without destroying it, that I could then swap this one with the one on my car, but I'm happy to write all of this off and just wreck it in, as part of this video, as part of this investigation really into how it works. And then if I come up with a way in which it looks like we can actually do something to increase the power, then I could always then do that carefully on the one that's fitted to my car. Well, let's see how far I get. Very shortly I'll give up on this and I'll start undoing these, and we'll have a look inside there and figure out which of these positions is high and low power. Okay, so what I've decided to do here is loosen off these bolts here first and try and remove that, just to give me better access onto here. These bolts here are really baked on. They're very, very tight, because this piece of course gets red hot. I will apply some WD-40, try and loosen those, but I know they're still going to be very, very difficult to undo. So putting a spanner on there, it's just a recipe for grazed knuckles. I need to get a proper socket on there all the way around, and really give it some welling on those. So if I can get this piece out of the way first, undo these, remove that, then it should give me enough access to get straight into those. Okay, that's all of those bolts removed from the intake side. It was an 8mm it was an 8mm spanner that was required to undo those. You could try using an 8mm socket. I tried with a universal joint on there, but it was still difficult. So ended up with using a spanner. There's all those bolts removed, and now this actually comes off. There we go. So that is the intake compressor cover removed, and we can actually see the compressor blades there, very sharp. So that could be, looks like that little old sort of nut there. It can be undone and the actual compressor removed. There's a lot of oil here. Okay. So I should now have better access to these bolts here. I can actually get a decent socket, a ratchet on there. Use my sort of 1/2 inch socket set and apply a decent bit of torque to these bolts and see if they remove. Before I do that, I'm going to spray them with WD-40 just to kind of let that soak in, and then once that's penetrated in, I'll try and remove them, and we can have a look and see what's under the exhaust side. Okay, so I've removed these 5 10mm bolts. So they're all removed, and I'm making the assumption that this is very similar to this piece here, where it's just the bolt heads literally held this in, and when they were removed that just came off. This looks very similar. You can see where the bolt heads overlap, but nothing's kind of moving, so I think I might have to just give it a little tap with a hammer or something. It's probably just seized on where it's got rusty. Hopefully I don't have to start undoing these nuts on the turbines. Hoping that will just pop off at some point. Might have to carefully give it a bop through there in the middle so I don't damage the turbine vanes, but just give it a knock and that should all come out. But yeah, it's not obvious really. There is a little gap here with what appears to be a bit of tissue or something stuck in it. Let me just see if I can carefully use a large flat blade screwdriver. Come on. Oh, no, that isn't tissue, that's some kind of fire cement or something. Okay, I might try and dig that out and then give that a bit of a prising. I'll have to be careful that this doesn't go crashing down, damage itself too much, although I don't think this will ever be fitted to the car again. Okay, so I've managed to prise it apart. So what I did is I cleared out the stuff, whatever it was, white powder stuff that was in that bit there, and then just very carefully prized this, and the whole thing is coming apart. Ooh, there we go. So, what is in there? Goodness. Right. There we go. So, there we go. Put that down. This is actually a little kind of shim, sort of metal ring, which unfortunately I've now flattened on where I got the screwdriver in there. But can release this clamp now. Right, okay, there we go. So this piece is just a chunk of iron. Okay, so you can see there how the exhaust gases will come in and then spiral round before exiting through this hole here. Okay, so let's just pop that on the ground for now and see if we can work out what is going on with these. Oh, look, there we go. Okay. Right. So it looks to me like, and I might be getting this wrong, but that I think is the lower power setting. Videos and sort of animations and things I've watched online suggest that that is the fast spinning mode. That's the position where the turbine spins as fast as possible, and then that is slower. You could be forgiven for thinking it's the other way around, because you're thinking, well, there everything's kind of a bit closed up, and then we're letting exhaust gas into the turbine, which you can just about see in there. And maybe I've got this the wrong way round. Because with that closed off, the gaps are very, very small there. So the exhaust gas is going to come in, it's going to sort of whirl around here. I don't even know how it's going to, it's got to come out through here. So maybe it doesn't close up that much, maybe that it's sort of ajar like that, and that's like high speed, and then directing the gas more towards the centre of the turbine, which will make it spin slower, is that position. Okay. I think what I'll do is get this all cleaned up, and then I can actually have a better look at it without getting absolutely filthy. And I'll also put a couple of pictures up on Instagram and on the Facebook groups, and just see what people think. Is that slow or is that fast? Okay, we'll leave it there for now, and then I'll come back to this tomorrow and give it a bit of a clean up. I'm going to give this a bit of a clean up now with some of this brake cleaner, just so that we can get a clearer view of what's going on. Okay, so I've just given this a bit of a clean up, looking a bit better, not quite so much carbon and soot all over it now. This is as far as I'm going to dismantle this turbo. there are a couple of Torx screws here which would allow me to remove this sort of piece around here and then get at the sort of moving ring that controls the variable vanes, but I'm not going to do that. I don't think there's any need to go deeper than I have already. We can see how this works. There's the compressor, there's the exhaust turbine, and this lever here operates the variable vanes in the turbo. Okay, so I've been doing a bit of research lately to try and find out which position of this lever is the sort of high boost maximum performance position. Okay, now when you look at this, your first thoughts are, well, there it's kind of closed everything up, and there it's opened up the gaps for the exhaust gas to go down and through. So the obvious sort of thing that I thought at first was, that's low power, that's high power, so it would run in that position to start with, and then as the boost increases and reaches the maximum boost for the engine, it slowly closes these and close up the gaps there so that the gas can't go through there. But when I've read up on the internet about this, and I've watched other YouTube videos and talked to various experts on the Facebook group, I've realised that all along I've got it completely wrong. That is the low power position, and then there, or close to there, is the high power position. If you think about it, the exhaust gas going through here is going through wide holes, okay? So the gas is not being blown at high speed into the turbine. So the gas will go through and out, and the turbine will spin, but as this lever moves and those gaps get tighter and tighter, it's going to sort of funnel the exhaust gas. It's a bit like sort of blowing with your lips together. If you watch a child blowing a little toy windmill, they're going to put their lips together to blow at high speed. Okay, they're not going to blow with the mouth wide open, and it's exactly the same here. That will send the exhaust gases at lower velocity into the turbine, and when you close up the gaps, the gas is then sort of jetted in at very high speed, because the area, the surface area that it can go through is a lot smaller. Okay, so the other thing that I've learnt is that these variable vane turbos, it's not just about limiting the boost. It's not just about going sort of full power and then easing off at the top end. It's also about increasing torque at low revs. So if we didn't have these variable vanes here, then at low speed, low engine RPM, when you're wanting to accelerate, this turbine is just going to be spinning at low speed. But by moving these vanes here, you can spin it faster for a low amount of exhaust gas and actually get the turbo to go faster than it normally would. If you had an old style turbo with a wastegate, the wastegate would be closed at low revs, but there's nothing you can do to make the turbo spin faster. The exhaust gas flows through it, it spins as quick as it's going to spin. But by closing up these gaps on a variable vane turbo, you can actually sort of inject the exhaust gas onto the very tip of the turbine, which is going to spin it at very high speed. And then as the revs rise, the ECU will tell the actuator to move slowly to this position to reduce the turbine speed. Now don't forget, at higher revs you're going to have a lot more gas flowing. Okay, so what it's doing is allowing the turbine to spin up to high RPM very quickly when the engine is at low RPM, and then by adjusting this it can hold the turbine at a high RPM without over boosting, without lag. Okay, so the lag is reduced because the turbine is already up to speed nice and early, and as the engine RPM increases and the exhaust gas volume flowing through increases, then the actuator will move to that position to not slow the turbine down, but just prevent it from getting any faster and going too fast and over boosting the engine. So now that I've figured that out, what we need to do is hold this arm in that position longer and move it to that position later, okay, at a higher RPM or a higher sort of gas flow rate. Okay, so what will happen then is, in that position, the turbine will be spinning nice and fast, and by holding this lever further that way than it would normally be, the turbine will spin faster than it normally would, and the result of that is that this compressor will spin faster and you get more boost. That is my theory. Okay, that is what I'm going to try and achieve. How do we hold that lever in that position longer? Well, I was hoping to do it with electronics, although the control box, the actuator circuit board, is just too complicated to try and do anything with. It's not a good old-fashioned analog electronics. It's digital. There's a microchip on it, and everything's done with data buses and commands and things like that. So I don't think really that's a starter. But what I can do is do something with the linkage so that the movement of this is delayed and happens later in the rotation of that little cam that is sort of turning, a crank that's sort of turning and pushing that. So that is what I'm going to try and do. So here's part of our actuator. Okay, so the motor's been taken out and the circuit board's been removed. We're just left with that lever and then this sort of worm drive mechanism which is attached to the other side. Now, I've tried prising off that lever, I've tried pulling that out, it doesn't want to come. So I think what they've done is, when they've assembled this, they've put that in and they've kind of welded that over or hammered that flat. So I'm going to get either my Dremel tool or a drill and try and remove that little sort of weld there. I think that is just the end of a shaft that they've just hammered to enlarge it slightly and stop that this sort of black piece from being removed or falling off. So if we have a look at how that used to sit, that was kind of there, and then there was a linkage between here and there. So as this moves from what I call the 1 o'clock position, so if that's 12 o'clock pointing up, it moves from 1 o'clock to 4 o'clock. Okay, and we now know that this is low RPM, high RPM. The vanes are in that position, and then as the engine speed increases and the velocity and the volume of the exhaust gas increases, it moves to that position. So on this, 4 o'clock is high engine RPM, and 1 o'clock is low. Okay, so what we need to do is hold it in the low position longer. Okay, so we are holding it in that position for longer, and then only going to that right at the last minute, and possibly not even as far as it used to. So we'll hold it there and then move it to say there, rather than going from there all the way to there. Okay, so what I'm going to do is try and remove this and see if it's possible to refit this further round, just sort of about 30 degrees further round, maybe not even that, just so that that thing there is at the 12 o'clock position instead of the 1 o'clock position, so it goes from 12 to 3 instead of 1 to 4. It might need a longer linkage, okay, might need a longer linkage because obviously this will be further round, but that's fine. I can make something that's slightly longer. Right, I'm going to leave it there for today, and then tomorrow I'm going to try to grind this off and see if I can rotate that. If I can, then I'm going to do a second video in this series and have a look to see if it's possible to actually make this modification on my real turbo, which is currently bolted to my engine, and then test drive it and do some performance tests before and after, and see if it actually works. Okay, so after a bit of drilling and a bit of hammering, I've got that off. Okay, but it's not sitting on a kind of a splined shaft or anything like that. It is literally just sat over there and then welded over, or hammered down or something like that. I don't know if it was really welded. It was just kind of like a press fit onto there. So that is now free to be repositioned. It would need some way of bolting that down into the new position. Unfortunately, I've destroyed the kind of thing that was on the other side, the sort of rack part of the worm drive. This kind of weird sort of circuit board thing, which looks like a sort of a inductance or a capacitance or something like that. So yeah, well, this was never going to go back on the car, so it's really a destructive investigation. I'm wondering if it might be better leaving that as it is and then making some kind of alternative bracket that maybe this piece is removed and it's bolted in so that this peg is actually here instead of the position it's in, and that way this whole arm bit can just be left as it is. Looks like I'll have to get another one of these on eBay and find a different way to do this, because even with that removed, I tried hammering that out, it's solid. I don't know how it's attached. There must be a nut or something underneath there. Maybe that's just kind of glued down, I don't know. But that just doesn't want to move. So it's not going to be very easy to push that out and rework it. Okay. Okay, well, that's as far as I'm going to go with this. I can't really get into it any deeper than that. I just wanted to know how that was attached. And it literally just sits on just like that, and it's then welded, so there's no kind of thread or splines or anything that sits on. Okay, right, well, I think we'll call it a day on this video. I've dismantled the turbocharger and I've dismantled the actuator. In the next video I will come up with some ideas for altering the linkage and the position of that kind of crank piece there. I'm going to have a bit of a think about it though. It's not quite as easy as I thought it was going to be. Okay, hope that video was useful. That was part one of a series of videos looking at ways to increase the performance on the Freelander 2. In the next video I'll continue my experimentations and investigations and let you know what I come up with. See you in the next video. Thank you. Bye.